Guys, good morning guys. This time guys, I will teach you guys the ER control about for A10VO series 52 and 53. I show you guys. So this one guys, I strip this one and still have one to strip. But have you encountered this type of controller guys? So there's a coil here. So this one ER72 because 72 is 24 volts. So that's why it's called ER72. Alright, so this one here is the pump displacement will vary by the solenoid signal or milliamps. So it's a proportional, not inversely, but proportional. So more milliamps, more pressure. So this piston here, actually guys, this is the new style, okay? Before, the notch is here, this side here, and now it's here on the other end. Okay, it's opposite now. Okay, sorry for my nail guys, I smash it. It's painful. Alright, so this is proportional control, meaning the more milliamps, the more pressure. Okay, so this is your Evan.
Sorry, mate.
So this area here, we know this already. I explained this type of, but not this ER, the DFR. So this is your flow compensator, and then this is your pressure here, or the pressure cutoff. Okay, so now I show you the cross-sectional. Hey, okay, see that guys? Okay, the top one is your flow and then pressure, but it affects this one here. If this one drain, then obviously the spool here, so only this spool will move. Here nothing. This here guys is only for spring tension adjustment. Okay, now this is tricky when you test this kind of pump. Okay, I'll show you. I explain that later. So you notice the spool guys, I just draw the drilling because in this drawing there's no drilling, so I put that. If you look on the actual spool, there's a drilling. Okay, now let's say, alright, this is okay. You notice the notch guys, open to the case. So this area here is case. Okay, let's highlight the drain. Okay, we put yellow there. If that notch is exposed to drain, so that pressure here and spring force overcome by the force of the system, then this will shift and then the pump will decrease the displacement. So remember, if you want to learn the DFR principle, watch my video guys, I explained that. So this one here is drain. So this thing here as well. Okay, drain. Notice guys here, see it's exposed, so your A is exposed to drain. Okay, so let's put that drain because it's exposed. So later I will show you the circuit of this diagram. Okay, and this one as well. All right. Okay, that's drain. All right. Okay, now we gonna color the system pressure. Okay, system pressure here. Okay, so that one there, system pressure won't go there because it's sealed. Okay, so this is PAT. Okay, so I'll show you that on the diagram, guys. Alright, so this is system pressure. Obviously the orifice, the drilling is exposed to system pressure. System pressure will not go on this other side because it's sealed by the spool. So very important, guys, when you strip this valve, you need to measure the clearance, the bore between spool and bore. Okay, man?
I'll give you this for the feed motor.
Yep, no problem. So here, drilling, obviously this drilling here exposed to, okay, so there's a pressure acting behind that spool, and drilling system pressure all the way here, and then obviously this area here, follow, guys, follow. This area here is exposed to what? High pressure. So see here, that's a port for the export. If you put a gauge there, you will see the pressure system, but there's a delta P because of that drilling. Okay, and also see this drilling here. Yeah, you follow, guys. Okay, system pressure. Okay, so and then coming here, exposed to piston, exposed to here, system pressure. All right, system pressure. I think so, this one as well. Obviously the system pressure exposed to this notch. Okay, all right, watch out, guys. Okay, if there's no current, okay, what happened is this piston will move all the way there, and then see the notch exposed to drain, so meaning you're in standby mode. All right, hang on. So remember this one here, huh? Okay. Okay. This is your Q, delta P. So you can do this one, guys, like that, oh. Okay, and then you can do like that because it's remote. It's remote, guys, it's remote. Okay, right, so you can set that, you can set this valve on this curve. Okay, so no solenoid, so meaning, guys, I will, so that one, okay, that one, okay. So what happened, guys, is milliamps. So this one is 50 to 600 because it's 24 volts, and then delta P. Okay, so meaning start of control, let's say 0, and then like that. Okay, so meaning from, so this is the start right here, and then here, so 50 to 600 milliamps. Okay, so meaning at 600 milliamps you get your max pressure. All right, so if there's no signal, 0 milliamps on based on the graph before, on the flow pressure graph, it's standby. So because this piston will, so there's a pressure here, act here, and then there's also a pressure here, and because of that spring force, this piston will push all the way there to the right, and then the notch exposed to drain, and then it will go standby, because the more notch exposed to drain is the less pressure on your spring chamber here. Okay, remember guys. Okay, this is the circuit. All right, so this one is a remote control but solenoid operated, proportional. Okay, see the circuit, guys? It's like a DRG. It's a remote. See, when the spool has a drilling, meaning it's a remote. If there's no drilling, so it's a load sense type. Okay, or DFR. So what happened? See here, through orifice, this one here, that's the drilling. That's the one. Okay, so what happened is the spring here on this spool, which is this one here. Okay, the spring force here, the force that acting on this side is spring force plus the pressure. See? Okay, so once that force overcome by the system pressure, this will shift, and what happen is your pump will go minimum, whatever the consumer demand. So okay, so it's a remote control. Let's say you got 50 bar only, and then the system pressure, once it reaches to 50 bar, this one shift, and then the pump will start to decrease the displacement. Okay, now this one here is this one. Okay, you notice, guys, that this spring force is based on this adjustment here. Okay, so that's the one. Actually, this one has a, okay, let's put this. Okay, balance. You see here, pressure act on that side, in that area, and act also on that area. Okay, so I explain this later again, guys, because I have something to do first. Okay, so here we can check the circuit diagram of this control here, the LR. All right, or the ER. Okay, so this is the ER circuit. So ER72, 72 means 24 volts, and the start of control is 50 milliamps up to 600 milliamps. Okay, this one here. Okay, so this portion here, this drawing here, okay, hang on, this one, this is the piece here. Okay, so this is this adjustment, this is the one. So that's adjust the tension of the spring, and proportional solenoid, and then we have the piston, which is number 4. Okay, number 4 on the drawing. So let's trace the system pressure. Okay, system pressure, this one here, all the way to B port. Okay, this is A10VO series 52 and 53. Alright, here there's a pilot gallery but still a system pressure. Okay, so let's trace this one. Okay, there. So this area here, this is the one. This at the back. Okay, the back. Okay, so system pressure through orifice or drilling and then acting at the back. So this one here. Okay, and then waiting. Okay, so close, so pressure is waiting. Same here. Okay, close, so pressure is waiting. Okay, then okay, from there through orifice you can put gauge there if you want, acting on the spring chamber, that one there, through orifice acting on the spring chamber, and then all the way, see here, all the way to the proportional solenoid valve, so which is this one here. That, so there's a pressure on the spring side acting on that, which means the area, so this area here, so that's spool. Okay, so here, this one, so that area there, there's a pressure acting there, and then there's also pressure acting in this area, so this one here. Okay, alright, then I'm gonna trace the drain. Okay, okay, let's trace the drain. So here, drain, so this one here, this side, drain, drain. Okay, and this is your A. All right, A. I just put that A because that's where the this is your control gallery going to your stroke piston. Okay, so in the drawing here, this is P, A, and T. Okay, so what happened, guys, is this one here, when the solenoid or the milliamps is 0, the pump is standby pressure. So here, watch, 0 milliamps, standby pressure. Okay, so what happened, this will, because there's a pressure acting here, so this one, this piston shift, so like here, so there's a pressure acting in this area, so once there is no solenoid, where there no milliamps, that will shift there, plus the spring force, so this notch is open to drain, and then you have standby. So the more notch, the less pressure here. Okay, it's like this one. Okay, it's like a needle valve. Okay, the more you open, the more you, so let's say the flow there, so the more you open, if you have a gauge there, the delta P is less. Okay, so P1 minus P2. Okay, the more you open, the delta P less. Okay, same here, the more that notch exposed to drain, the less pressure here, so meaning whatever your spring force here, which is your standby or differential, and that's the pressure that acts on here, so because you have a 0 milliamps, so all the pressure here is drain, okay, because that is 0, so drain, and then what happened is this spool shift, and then what happened is this, let's say this is P T A. Okay, so P to A open, and then what happened is P to A, and then A, and then stroke. So this side here max, obviously because of the spring, and then this side here is min displacement. Okay, so less milliamps, then the more this one shift to the right. Okay, so this is what happened. The more milliamps, the more pressure. Alright, so the more milliamps, the more load you can get here on your pump, because this will act as your flow compensator. Okay, alright, so as you notice guys, there's a pressure act also here. So meaning if you wind this all the way, this one here, watch this spring here. This is tricky when you set this valve control. When you wind this all the way out, this one here, less pressure here. So what happened, this spool will shift to the left. The more it shifts to the left, the less the exposure of the notch. And then what happened is you see here, this area is sealing. So once that happened, then you have max pressure there. Even so, you have max pressure because what happened is this one shift to the left, and then you have your milliamps. Okay, so that happened, you have a max pressure, and then it will not cut off. Okay, because it's the area here is bigger than the exposed area here. So you're gonna watch out. So when you set your pressure cut off, okay, milliamps out, off. Remember, milliamps off. Okay, milliamps, okay, no, milliamps on, because this is proportional, it's not inversely. So what you're gonna do is to set the pressure cut off, you put on max milliamps, so 600 milliamps. Okay, and then this one here, not all the way out, because if that is all the way out, then this will shift more there. Okay, instead of here. All right, so remember this area here. Okay, it's the area here, then the area here. This one is exposing to drain. If that shift to the left fully, then you sealed the drain. See, you sealed. Okay, I'll show you. So watch this guys. Okay, so see this area here is solid, there's no notch. Okay, hang on. Okay, see this area here is solid, no notch. So if that solid block the drains, and then you don't have drain. Okay, so what happened is sealed, because the spring there at the other side is so weak, or like all the way out. Okay, so, and also by the way guys, the diameter here is bigger than the diameter in this one. So watch. So this is the, okay, see, watch this one go there, see, but if I other way, won't, because it's bigger. Okay, this is 3.2. Okay, this is 2.9. Okay, so 2.9, 3.2. Okay, let me measure. Okay, okay, hang on guys, it's hard to so this one here 5.2. okay, 5.2 against 5.3, I think. Yep, 5.3. Yeah, 5.3. So 0.1 difference, so meaning the force is that way. Okay, balance to balance the what's this, against the milliamp signal. All right, but if the spring force there is like all the way out, okay, or weak, then there's a tendency this one, once the solenoid energized, this one move more farther to the left, and then this solid here will seal the bore, then you don't have a drain. It's like you closing the remote control relief valve all the way in, then you don't have a remote, so it's dangerous. Okay, so when you do the adjustment of the cutoff, you need to preset. Okay, you're gonna put your gauge on B. Okay, B port. So what you're gonna do is you wind the milliamps slowly, not full, slowly, and then before that, this one you preset. Okay, preset. Let's say before you strip, you need to measure. Okay, measure the height from here to nut, face of the nut, like what I did, guys. Okay, because I don't have a spec for this, what I did is say here I preset cut off 11.92 millimeters. Okay, so you set this to 11.9 preset. Okay, and then you wind the solenoid milliamps to 600 milliamps full, and then slowly wind in the load valve. Okay, and then let's say 280 bar. Okay, 280 bar, wind the load valve. Load valve means on B. So when you test, guys, the pump, so you expose this one here is you put relief. Okay, you put relief. Okay, this one drain. Okay, and then flow meter. Okay, so you wind this load slowly, and then you set that to 280 if that is your setting. Okay, 280 bar. Okay, 280 bar. If 280 bar is reached and then the pump is still displacing flow rate, because you have a flow meter, then the spring here is more force, so you less this adjustment here. Okay, and then until you get your 280. Okay, now the pressure differential, to set that pressure differential is half the milliamps. Let's say 400 milliamps, set that to 400 milliamps. Wind the load valve slowly until the pump went to minimum. Okay, until the displacement is minimum, and then you read the B pressure, okay, and the X pressure, and that is your pressure differential. Because you have an orifice here, it will create pressure differential because this one will bleed. Okay, that's because you set this to 400 milliamps. Okay, now if you set this to higher milliamps, then you have pressure cutoff setting. Okay, that's to guard the pump. Okay, otherwise it will displace infinite pressure. All right, so what these guys here, this piston here, you can see in the drawing, it exposed the notch to the drain because your milliamps is 0. Then when it start, then you have standby pressure. Okay, so remember, the less milliamps, the less pressure you get into the system. So when it is 0, then you have standby. Okay, so this piston controlled by this signal here. Okay, so that's how the ER control works, guys. Okay, so this is a new style. Before, the notch is here, this side here. So it's the same, guys, you know, it's the same principle. So this one, the less milliamps, so this one, the more push, shift to the right because of the spring force. Okay, it's kind of like this. All right, so that's it. Okay, I don't want to explain further. That's how it works, the ER72. Okay, all right. So by the way, guys, the reason that they changed into new style like this, before the notch is here, so meaning the spool is moving to the left, overcoming the spring force against the pressure, because this at the back is a kind solid and then it's sealed. So before, guys, is inversely proportional. So let's say you have a 0 milliamps on the solenoid, and then obviously because there's no draining here, it sealed this area. So the tendency is the piston, this piston here, will shift to the left by the force of the pressure, force of hydraulic against the spring force. So meaning the more force on the spring, the more pressure you get here. So when it is off, then you have a cut-off pressure. Okay, the problem, guys, before, when this cable here is cut accidentally, then instead of standby, unlike this one now, when this one is 0 milliamps, then you get standby mode. Before, when this is 0 milliamps, you have cut off mode, so which is like not really ideal, because if there's accident or maybe accident cable cut, instead the pump is going to standby, it will create more pressure. Okay, so it's dangerous. To eliminate that danger, if there is happen that the cable will cut accidentally, instead the pump going to max pressure, it will go standby, which is around 60 bar, 16 to 25 bar only, depend on standby setting, depend on this spring setting here. So that's the safety. I think they changed it into this style here. It's the same principle. You still have set the cut off by this spring, because there's a force here acting on that, and then the force of the plunger by the milliamps is against on this spring force. Okay, so remember, the more this one push to the left in this situation, the more pressure you have here. because the notch is exposed less to the drain. Okay, the more this piston shift to the right, the less pressure you have in this chamber, and then this will shift. Okay, this will shift into whatever pressure you have on that chamber, because what happened, this notch, the bigger notch exposed to the drain, so you have less pressure here, and then this shift to the right. Okay, so that's the only principle that I can look at it. So proportional, more milliamps, more pressure because less notch exposed to the drain. Less milliamps, less pressure because more notch exposed to the drain. Okay, so to push this to the right due to the spring force. Okay, all right, that's it.